Today I am going to solve the problems related to applications of first law of thermodynamics. So let us consider two problems. The first one is when a system is taken from state A to B along path ACB, 100 joules of heat flows into the system and the system does 40 joules of work. How much heat flows into the system along path AEB if the work done by the system is 20 joules, and the BPT is the system returns from B to A along path BDA if the work done on the system is 30 joules. Does the system absorb or liberate heat? How much? So to solve this problem, first we have to draw the PV diagram. So first let us consider the system initially at state A and it reaches to state B. So the first, it follows, to reach state B, it follows a path ACB. This is one path, and it so during this path, so let us ACB path. So what is the given value? 100 joules of heat flows into the system. So flows into the system, that is heat is added to the system. So the sign convention is the positive. So heat flow into the system is equals to 100 joules, and the system does 40 joules of work, that is work done by the system. So work done by the system is equals to 40 joules. So this is the dq and this is dw, and we know that according to the first law of thermodynamics, du equals to dq minus dw, or delta U is equals to q minus w. So heat is added to the system, that is 100 joules minus work done 40. So the internal energy of the system is for 60 joules. So now how much heat flows into the system along path AEB. So the system reaches a state B along a different path AEB if the work done by the system is 20 joules. So during this process also, to reach A to B, it follows a path E. So AEB, the internal energy is the same as ACB path. So AEB, for AEB path, delta U is same, 60 joules, and work done by the system is given. So that is W is given. Work done by the system is 20 joules, and we have to find out the heat flows into the system. So Q equals to how much? So delta U equals to Q minus W, or Q is equals to delta U plus W. So delta U is 60 joules and W is the 40 joules. So total 100 joules. So the heat is added to the system. Heat flows into the system is 100 joules. So now take the second bit. That is, the system returns from the B to A. So B to A means here the process is reversed. B to A along a path D. So BDA path. So the total energy is constant, but it has the negative sign. Why? Because it is a reversible process. Reverse direction. So the direction changes, therefore the internal energy sign also changes. So for path BDA, delta U is minus 60 joules if the work done on the system is 30 joules. So work done on the system means negative sign, that is 30 joules, So generally, suppose if you consider this is a system, suppose heat is added, means positive, and work is done on the system, work done is negative, and heat removal, that is negative, and work done by the system, positive. So these are the sign conventions generally we are used in the calculations. So delta U is minus 60 joules. Why? Because the direction is changed and work is minus 30 joules. Why? Because it is work is done on the system. So delta U equals to, we know that this is the first of the delta U equals to Q minus W. So Q equals to delta U plus W. So delta U is minus 60 joules and minus 30. So minus 90 joules. So minus 90 joules. So does the system absorbs or liberate heat? So that means here negative sign appears. That means the system is removed heat. 90 joules of heat is removed from the system. So this is about the first problem. Now coming to the second one. So second one is to calculate change in internal energy and enthalpy for 1 kg of water when it is vaporized at the constant temperature of 100 degrees Celsius and the constant pressure of 101.325 kilopascals. The specific volumes of liquid water and liquid and vapor water are at these conditions are 0.00104 and 1.673 meter cube per kg. For this change, heat in the amount of 2256.9 kilojoules is added to the water. So here some data is given. We have to find out the internal energy change and enthalpy of the 1 kg of water. So first we have to write the given data. Here mass is given 1 kg and the temperature is at 100 degrees Celsius and pressure, it is a constant pressure process 101.325 kilopascals. Then V1 is 0.00104 and V2 1.673 meter cube per kg, and heat added is 2256.9 kilojoules. So first we assume that it is a constant pressure the process. So now we know that for constant pressure process delta H equals to Q, because Q equal delta H equals to Q. So what is Q here? 2256.9 kilojoules. And now from the enthalpy relation, H equals to U plus PV. Delta H equals to delta U plus delta PV. If it is a constant pressure process, we can write delta of delta V. And we don't know delta U. So we have to find out the delta U. So delta U equals to delta H minus P delta V. So delta H is 2256.9 kilojoules minus P is 101.325 1.325 and delta V is 1.673 minus 0.00104. So finally 2087.5 kilojoules. So the enthalpy of the process is 2256.9 kilojoules and the internal energy is 2087.5 kilojoules.